Hey, all, Brad here. This is a Defender power supply, original linear supply um, for a friend, local friend Ronnie. He dropped it off. He was having some issues with his Defender, acting a little goofy, and he had measured some voltages, and coming off the supply looked low. So we brought it over, and normally I just rebuild these. I strip them down and rebuild them, but I figured I'd power this one up on the bench, put it on my load tester, see what it was doing, do a little visual inspection of some of the header pins and stuff like that. So here it is on the bench. Clean supply. I think he wiped it down a little bit and got the dust off, but everything's in place. It looks 100% original. Nothing's been monkeyed with on it. Maybe somebody replaced the fuses. I'm not sure. They're pretty shiny, which is fairly common. It's got original branded 2N3055, which is the Williams number on it, and then Williams also used their own part number here. So this was either one, it's a 2N6057, a 6059 will also work in here. This is the 5 volt power transistor, and this one over here is the 12 volt. So on the bench right now here, let me show you what we've got. So this is my dual channel DC load. So this is currently hooked up to the regulated 5 volts here. So this is voltage on the top and current on the bottom. And then the 12 volt regulated voltage on the top, current on the bottom. And that's the -5 volt supply I'm measuring over there under no load. But right now you can see the normal load on a Defender board set is about 1.5 amps on the 5 volt and maybe a half amp on the 12. So I'm running double the load right now. And we're pulling 4.7, and there's no adjustments on these linear. They do have a resistor you can cut, but there's no potentiometer or anything you can actually tweak. So that is below. TTL threshold is 4.7 volts, and by the time that voltage here at the supply would get through the wiring harness to the MPU and then all the way across all the traces on the board to the 4016 RAM or any other TTL, that would probably be way below the allowed threshold. So I'm running at 3 amps here. The 12 volts I have running double the normal current at 1 amp, and just kind of seeing what's happened. But doing it, when I first got this, I took some before photos, you'll see. But some of these Molex headers here, as well as the ones coming in from the AC from the transformer, definitely cracked, cold solder, I guess you'd call them. But they need to be redone. So I'll replace when I rebuild it. They'll all have new Molex headers with the square pins. There is. It just does not have the sill pad underneath it. It's got the mica insulator with the heatsink compound. I'll remove all that and use the silicone pads. And then we'll get all new electrolytics on here. I'll socket the voltage regulators here, one for the 5 and one back here for the 12. I'll put a 10-turn precision pot to adjust it up, and then we'll come back on the bench again and kind of look at these numbers. So over here we got -5.0, no load. Typically the only thing this audio board, the soundboard uses -5 as a reference, and then the -5 is also used by the 4116 DRAM as a reference as well. So very, very little current consumption on that. And then the regulated 5 and regulated 12 here. So you can see 4.7 way low, and I can turn that load off here. That's for the 12, and it bounced up a little bit. And again, with no load, 0 amps, it's still sitting 4.8, which is lower than I definitely like to see. That should be 4.99 or something in that area. So anyway, another video to follow up when some static photos along the way as we tear it apart and rebuild it. And then once I get it on the bench, I'll do another one. So thanks for watching. Bye-bye. Hey, all, Brad here with a follow-up video on the Defender power supply for Ronnie. I've got that all wrapped up now, and I've got it on my DC load tester, and it's been running for at least 8 hours total at double the normal running current, and I'll go over that with you real quick. So I'll show you what we did on the board. Completely stripped down. I did provide a photo album as well with some static images. This is the 10-turn precision potentiometer. We're just the 5 volt. We've socketed both of the voltage regulators. This voltage regulator is new. On the 12 volt, we've got some green LEDs installed, all new electrolytics, all new Molex headers installed. Here's a Molex, new there. Input from the transformers new. Obviously the large filter cap for the 12 volts is new. The gigantic 18,000 microfarad down here for the 5 volts is new. We've got a new bridge rectifier for the 12 volt, bridge rectifier for the -5 volt. On the -5 volt regulator, the 7905, I do install a custom heat sink for that, you can see here. And then also on the large BR1 5 volt bridge rectifier, I install a custom heat sink here. Did strip this board down and wash it in Simple Green, and you can see I reapplied the labels. I have a method of removing them without damage. Actually, I think I have some glue on my fingers still from reapplying those. There's also a label that was back here that's been reapplied. So again, new sill pads underneath both of the power transistors. This is a 2N3055 for the 12 volts and the 2N6057 for the 5 volts. Cleaned up, got rid of all the mica insulators and the heatsink compound, and now we just have the nice clean sill pads under there. And again, on the DC load, you can see here I've got 4.966 volts at 3 amps, and then at 11.8 volts at 1 amps. Again, the 5 volt circuit typically, like on a Defender or Robotron Joust, draws about 1.5 amps, and the 12 volts draws about 0.5 amp. So we're running double. So what I can do is dial that back down to closer to the normal running current, let's say of 0.5 amp here, and then I'll do the same on the 5 volt, and you'll see it will bounce up a little, so that's why so that's pretty close there, 1.5 amp, and you can see it's sitting right at 5.02 volts. I've got the 10-turn pot dialed in, and then this is on the 5 volts, a -5. You can see it's sitting right at -5.097, and I do have the ability here with this resistor to load that. And I've got a little LED indicator to show the -5 is loaded. And the 7905 voltage regulator is capable of putting out about 1 amp. The board draws nowhere near that. And this load resistor draws about 0.8 of an amp, 800 milliamps. So I usually run this for a minute or two just to make sure everything's solid in the circuit. But I just have a little switch here where I can turn that guy off. And she's rock solid, burned in, and ready to go back to the customer, provide hopefully at least another 40 years of life in a Defender. So thanks for watching the video.